So first we'll do is we'll learn ordinary least square regression, and we'll keep the results, and then we will robust regression, and we'll then compare the results from OLS regression with that of the robust regression, and we will see what the differences are. We'll use proc reg in SAS, and the data set is crime, and we're using two independent variables, poverty and single, and the dependent variable is crime. Other things, we also want the residuals, so that's important to us. We're also getting the cookd. So cookd is nothing but measure for outliers. It helps, it's just a statistics which helps you finding outliers. And we're also finding the leverage, and we also plot it, right? We'll plot the leverage just to know how many outliers do we have. So when we run this code, we have these outliers, right? And we can clearly visualize them, that these are some of the outliers. So that's one way of locating the outliers. The other way is to use the cook distance. Okay, so we use the cook distance. The thumb rule is that if the cook's distance is greater than 4/51, it's considered to be an outlier. Okay, and we found that there are 4 observations which are meeting this criteria. However, we can actually remove them, but given this is a small sample of 51 observations, it is not a good practice to review this observation and then go ahead with OLS. We have the R square of 70% and so on. And okay, so just one variable is significant. The single parent is significant, and poverty is not a significant variable. So that's the result from the ordinary least square regression. Okay, so you can also plot the residuals from the OLS regressions, and you can see that some of the residuals are far away from the other residuals. So there's a presence of outlier. That's what it confirms. So we'll use robust regression, okay, and we'll use robust reg in SAS to do the estimation. So when we run this, we will get this output. We have the parameter estimates. Here also we can see that just one variable is significant. I guess so. Yes, only single is a significant, poverty is not. So the result from OLS and robust says pretty much the same. But what are the differences then? And we'll see what the differences are. Okay, so when you look at the statistics, the diagnostic statistics, so what happens in let's say this is the data point distribution of data points, and these are some of the outliers, right? In ordinary least square regressions, the normal data is considered that most of the observations are normal, right? More general in nature. So the weight in the estimation, the weight given to all observations in the estimation process is same. Whereas in robust regression, the outliers are given less weight. So, okay, the outlier given a less weight in the estimation. That means the contribution by the outliers in your estimation process is much less compared to the observations which are not outliers, right? And it depends on the Cook's distance as to which one will have the highest weight and so on. So the best observation will have the most weight in the estimation process, and the weight given to this these good observations is actually more, and to the bad observation is actually less, right? You can see different weights given, right? And this is exactly is the difference between OLS and robust regression. So in OLS, your weight will be nothing but 1 by the number of observations, right? That is exactly the weight. Whereas in robust regression, it will vary a lot. Okay, so you can see the weight given to the first observation is 0.28, but the next observation is 0.35, 0.59, and so on. It is different. And some observations, it has been taken a weight of 1, which is the highest, right? Whereas in OLS, it is all uniform. The weight is exactly the same. Now we have seen that the results in the output hasn't been very different from what we have seen in OLS. However, in many instances, you will find differences. We haven't taken many independent variables. If you have a bunch of independent variables, some of the independent variables which are not significant in OLS with the presence of outliers will come significant in robust regression. Now, what are the uses, real world uses, right? We always worry about, well, theory is fine, but what the real world uses are. Well, I can tell you one example in finance where robust regression or robust statistics are very finding a lot of popularity. In finance there are some rare incidents where you have some incidents which are totally different from a set of other incidents which are pretty normal. And in finance, this extreme observation cannot be removed from data, but that's important. Like financial crisis, let's say 2008 financial crisis. So that's an incident which doesn't happen every year, right? So that's an outlier. All that has happened in 2007 and 8 in finance is an outlier in your data if you do an analysis in the later years, right? But will you be able to remove them? No, because these data points on in a crisis period are actually very important. So how do you deal with them? Well, the normal statistics is not going to help you much, because that will require you to remove observations which fall in these 2 years, 7 and 8. Whereas robust statistics will help you estimating without having to remove the outliers or these observations which are considered to be rare or extreme, or observations which do not occur in a normal time period, in a normal situation. All right, thank you so much, and if you haven't subscribed, please subscribe.